this supervisor consumer pattern, you said that so we need when I'm auto increasing the number of consumer based on the request pending in the queue.
Yep.
So let's say the request is processed using a backend database. So I need to increase the number of connections also, right?
Yes, that, yes, exactly. So the question is the number of connections. Do you remember this? There it is, apply a maximum threshold. This is where that applies. I may have constraints. Now, I myself am just an event consumer. All I'm doing is read a message and instantiate a class or inject a class. However, that class may be doing a request to the database, which of course it is. I have to be cognizant of the number of connections that I have in the database.
Yeah, because in database
Absolutely.
level, I will have one overall threshold.
Sure.
And then after that, I will get a number that only that much for this particular consumer I can have.
You got it. So, keeping this conversation going, watch this. Remember I told you, oh, I'm sorry. This is the inside view, remember, of this guy. Remember we just opened up the hood to the customer demographics. Remember I mentioned before we needed 7 instances because it was really, well, maybe I can get away with 2, but to your point, because of constraints on maybe database connections or threads, I may need 3 or I may need 4. And so I do need to know those throughput values, but it's also applying those kind of constraints. Yep. So what I want to do though with this question is I want to cache it. I'm going to table it because I'm going to actually talk about database connections and the problems associated with those.
Okay.
So let's see, traceability, DB connect. So let's keep this question. I've got it on the queue here. So I should, next time, I'm going to do this next year, I'm going to make sure I have an easel so that I can write them down so you guys can say, you didn't cover that one yet. So this will be our easel right now. How's that? Except only I can see it. So database connections. And so let's table that because I want to talk about the database connection constraints. Okay. So, but let me show you another. So we just spent a lot of time on messaging. It's a really good option. Whoops, we already saw this. But let me show you another alternative that is trending in the industry that you should probably be aware of if you're not already using it. And it is gRPC, Google's Remote Procedure Call. So this is also trending to say, is there another way to be able to communicate between services? Sure, gRPC. And as a matter of fact, let's expand these services and just scope this because there's our wish list and demographics. Well, instead of using REST or instead of using messaging, how about gRPC? If you want to get more, I'm going to show you how it works and then whether you should use it or not. But if you want to really dive into it, it's grpc.io. So here's what happens. When I download and install gRPC, the customer demographics service is going to have some sort of client. So gRPC is kind of a wrapper above Google's proto buffer, basically, which is an IDL. And what it is it sits on top of HTTP2, which is a persistent connection. The average benchmark is 10 times performance increase over REST for communications between services. So now we have even a 4th option of how to increase performance, gRPC. So if I've got a lot of inter-service calls, I've got a lot of latency, I can reduce that 10-fold. If I've got 100 milliseconds, it now goes down to 10 milliseconds. And so that is its big use case. Okay. Why wouldn't you use it then? Let me show you why. Let me show you how gRPC works and show you why you wouldn't use it. Hold on one second there because I want to show you actually how this works. And so here's the point. When I download it, the demographics service is going to have a gRPC server. In other words, this is a server code. This is a server library of how to connect to me. And then on the client side, I need gRPC client installed right here. It's a client stub. Basically, this is very similar if you've ever done coding or are familiar with EJB. This is RMI over IIOP, EJB stuff. You know, I need your interface. I have a contract. And so this is like a local call. If I need to get the name, what do? I go to the client stub and I say, get name. And it gives me the name. And the client sub, like RMI, abstracts the access point of knowing how to get this persistent connection and then send it back to me. And that's how gRPC works. It gets its performance from twofold. One, it gets high performance because of protobuffer. Protobuffer is a highly compressed stream of bytes using protofiles that are sent across the wire. Add on top of that a persistent HTTP2 connection. Man, this thing is so fast. Did you?
So we got these three ideas, like REST call or the messaging and the gRPC.
Yeah.
We can never actually predict which we want to use before going to production. We need to see one thing fail, then only we'll go to the next thing. Because if we directly go to gRPC, we may end up in a complex system, and
That's right.
so we need to actually see it in production and then change our strategy.
Yes, and as a matter of fact, that's a good lead-in into my point. So, so you're absolutely right. Although with the REST piece, I usually do start making assumptions about messaging, because now I do have async, and I know that maybe my async needs. But yes, usually I wouldn't jump to any of these unless I had a need. In other words, if REST is fine and we have plenty of latency, maybe I don't care about the latency. I do care about the API, though. But yeah, let's talk about this gRPC, though, because 10 times performance increase. Who wouldn't here use that? Me? Why? Because I am tightly binding these services together. I have a piece of your code. I break the bounded context and I tightly bind services. As a matter of fact, there's optimizations unlike EJB or EJB3 or whatever. EJB3, I guess. I haven't coded EJB in a while. EJB3, RMI over IOP. I cannot start up my application unless you are started up. That is dependency. That's what I mean about tightly coupled. I have a persistent connection to you. If you're not available, I can't start. Now, gRPC has options to say, well, I'm going to let you start, but you're not active until I get that connection. And so the problem is we are tightly bound. With REST, are you up and available? I have no idea. I haven't made a RESTful call yet. Messaging? No clue, because I'm not talking to you. I'm talking to a queue. It's even further decoupled from there because I'm not actually talking to your own endpoint. And so the point is, plus or minus, 10 times performance increase, tight binding. And this is the topic that you're referring to, which is really about premature optimization of performance. I see this way too many times. Rich Hickey comes into play again. Programmers know the benefits of everything. 10 times performance increase. And the trade-offs of nothing. Tight binding. Which is more important? Let me give you an example. Our SLA is 2,000 milliseconds, 2 seconds for every request. That's our SLA. We have to respond within 2 seconds, period, for every request. My current request is at 300 milliseconds. 300. I have a 1,700 millisecond buffer. Why am I trying to shave off 40 milliseconds? I don't need it. Why am I trying to overcomplicate my code with all sorts of really complex programming logic to increase the performance when in fact we have 1,700 milliseconds buffer? That's the question. So to your point, absolutely. Is there a need for that? And in most cases, I have found no. But in cases of extreme performance or we're having latency issues, this is a solution. Please understand the trade-offs. Tight binding, higher performance. Do I need to shave off 40 or 50 or 60 milliseconds? In high-speed trading, yes, absolutely. And there's one other place where I will tend to use gRPC, and that's something called service chaining. I know that that was one of the issues about service chaining here that I saw. Service chaining is where we have more of a pipeline kind of architecture, very similar to serverless. If I'm going to do a function upon a function which calls a function and does this pipeline through triggers, the key point is those I will tend to use gRPC for. Why? Because in a pipeline, this isn't like service chain, well, this is service chaining. This is not choreography. What I'm referring to, well, it is, but it's chaining. In other words, the request comes in. Where's my buddy Manoj? There you are. Goes over to Manoj. Manoj does something with the data and then sends it over next door to him. And then you send it to you right here, and you send it over to you, and then it ends. Well, that's the request flow. It always is the request flow. And so the point is, all four of you are kind of tightly bound anyway, because it's part of a single request, chaining, not orchestration. I'm not orchestrating you. It's more of a pipeline flow. That is probably a good use, because I can increase performance, and the trade-off is the fact I'm tight binding. Well, we're already tightly bound. And so that's a good use
And
case.
in that case, we already decided that when we choose the chaining pattern, we already decided that we are okay with the asynchronous mode.
Yes, or asynchronous.
Yeah.
Asynchronous might be another good choice. But here's the question, though, about gRPC. I've got 4 instances of customer demographics. Which one am I actually talking to? Oh, this is a persistent socket connection. Uh-oh. How do I do this? Let's actually analyze how I would do load balancing with gRPC, because this is a different protocol now. And this is gRPC LB protocol. As a matter of fact, if you're using gRPC in microservices, you will always use gRPC LB. So your question about, up above here about the transport cost, now this really comes into play. Now we're really going to see your point about additional hardware and network, because how in the world do I talk to these? There's 2 modes. This is the cheap mode right here. What I'm going to do is I'm going to use something, oh, by the way, I've got a sidecar right here. A sidecar is a service that sits right below your functional service, right in the same Docker container. And what it does is it's another service that sits right below it. It's called a sidecar, kind of like on your bike. You know, you've got that little sidecar thing, hopefully. I've seen too many people on handlebars. That's just not safe. No, use the sidecar. No, that's not safe. Do you know how close cars come to each other here? No, that sidecar's, whoa, where'd you go? Uh-oh. Anyways, I love your guys' traffic here. It's just amazing. Oh, my word. Have I got stories to tell? This is my first trip, as you can tell, to India. Have I got stories to tell when I go home? Oh, you know, the traffic in Boston is nothing. Now, you know, this is something I love all these tangents. Something I call the threshold theory. I think that's a theory in life. It's called the threshold theory. That you reach certain points of experience, and you usually don't cross over those until you've actually had an experience more than that threshold. And that becomes your new threshold. And so anyways, I will never in my life ever complain about the traffic in Boston again. That crossed my threshold, yes. Oh man, it is amazing. You guys are expert drivers. You do not need stop signs or lines in the road or even directions or lights. No, that is expert driving. We are amateurs. We need stoplights. We need lines in the road. We need, oh gosh, this is amazing. What were we, oh yeah, sidecars. So what we have is something called the gRPC LB. The LB stands for load balancing, a gRPC LB policy. And it's a sidecar policy that sits next to our service right here. So here's exactly what happens. So I'm going to have something like this. In this particular case, I've got 2 options. Here I'm going to use something like Zookeeper or Console or etcd. In other words, it's just a service registry and discovery. And all of the customer demographics, now watch the arrow direction, register with Zookeeper or Console. Now, the load balancing policy, in other words, when I say load balancing policy, what I'm really referring to is, do I do round robin, first available? Out of all 5 of you here, who should I probably talk to right now? That's the load balancing policy. It sits with me, the wish list. Actually, formally, it sits with this sidecar right here. And so now, notice that the gRPC client stub is communicating directly with the policy sidecar. Now, here's what happens. I need to make a call to customer demographics. Which one should I use? Well, the gRPC policy sidecar checks in with Zookeeper and says, how many instances are there? There's 4 here. Okay, well, maybe I'll do a round robin. So then it instructs the client library to call this one right here. And so you can kind of see this is kind of a virtual load balancing capability. This is not a true load balancer. However, and it's pretty cheap, but it's a little slow. Okay, let me show you a faster gRPC load balancing. And so in this case, I'm going to use something like traffic. I like traffic. As a matter of fact, if you are going to think about or prototype gRPC, I would recommend downloading traffic. It's a software-based load balancer. As opposed to like a Juniper. It's not Juniper traffic, which is a hardware load balancer. This is software, and it's a very common one. And so what traffic is going to do is oh, and by the way, the other complexity with gRPC is that your load balancer has to be protocol aware. And traffic, and it's spelled T-R-A-E-F-I-K. And so if you go Google it, you're going to end up with Juniper's network. So it's T-R-A-E-F-I-K, traffic. This is a combination you're likely to see. Anybody who really uses gRPC generally uses traffic. Okay. So here's the point, though. Traffic is going to be, it's gRPC aware, so it knows about that protocol, and it's going to be doing constant pings to all 4 of you. Demographics, folks. And now, so it knows, it has the policy. And so now I need to make a call to one of these. Well, the gRPC policy just asks traffic to say, which one should I use? And traffic says, go here, because that's the one that's performing the best so far. And that requires infrastructure. That requires licensing fees. If you're using hardware-based load balancer, make sure that it's protocol aware. But the point is that's going to require more infrastructure in your network. Transport cost is 0. Remember that. There's no transport cost. That's a fallacy, yes. All right. Let's take a look at an API. So that's gRPC. I wish I could spend more time on it, but I want to get to caching. Let's talk about the API gateway. Now we get to really peel the onion back on these gateways. And so instead of a API that's just a proxy, what I'm going to use is now a gateway. And the gateway can be implemented in any of these, as we saw earlier this morning. It could be custom written. I could use CAs, IBMs, BizTalk. I can use Mule. I can use Camel, Spring Integration. And you say, that's just an integration hub. That's right. Here's why I was saying you will need a gateway or a service mesh for these reasons. 1, how do you handle security? What a great way to handle security, because that requires code, right? I have to have code that goes out to Active Directory or code that goes out to LDAP or whatever you happen to be using, let's say in Spring, for example. That's actual source code. I can't write source code in IIS or HA proxy or Squid or Apache. And so in that case, I need some code. Well, what better place to put that than in a gateway? And actually, I'm not being sarcastic. I'm actually being serious. What better place to put that than in a gateway? Security, I can secure every endpoint because it comes into the gateway. Now, don't forget, this is federated. I've got my policy gateway, my issuer gateway, my claims gateway, my quoting gateway. And so I've federated the gateway as well. But I've got the security baked in right there. That's perfect. Another good use, every single request, now I get to talk about traceability. Every single request in our system has to have a unique request ID, a UUID. Okay, granted, that's only 2 pieces of software, or 2 lines of Java code, but I still need to generate a UUID with a seed, or a GUID. That requires source code. What better place to put that than the single entry point of every request in our system? Perfect. Okay, and that's, by the way, how to support traceability. Is through request ID. Now, usually in distributed logging, we need this for Splunk's correlation ID or Loggly's correlation or Logstash's correlation ID anyway. But that's a great place to put it, right in the gateway, because every request comes through it. How about this? Every request we have in our system must be audited. In other words, we need to track who's grabbing what information from what kind of area. And so this is a wiretap. What better place to put that wiretap, which is source code, than in the gateway? Wiretap the request, go insert it into the, we'll say that little hot spot there is our audit table. Go insert into the audit table. Ooh, it turned blue when I probably just messed up our wireless. Sorry. Anyways, Auditing, perfect example. Distributed logging, if you go to the developer-to-architect.com, go to lessons, lesson number 2 is how to do distributed logging in microservices. You'll need to extract a context ID. In other words, distributed logging does generally leverage a request ID, but also, I also need a context. So when we talk about traceability and auditability, I need to look through the payload for what is the context. In other words, is this a claim? Is this an account? Is this a customer? Is it an order? What's the context? And what is that order ID? And what is that claim ID? What is that transaction ID? And so I need to extract that. That's a lot of programming code. What better place to put that than in the main entry point? These are all great examples. As a matter of fact, I'll throw out one more example. I usually, in most of my microservices ecosystems, leverage Kafka, Apache Kafka, to be able to stream all of the time stamps, or the durations out from every one of my microservices. I stream all of the uptime as well, so I can tell the health of my service. So I know the duration, the min, the max, the standard deviation, the variances of every single one of my services. And all the duration. In other words, how long did that request take? The problem is, I know every single solitary one of you, but I don't know the request. Now, I can usually leverage the request ID to try to build that, but that's a lot of complexity. I can use the endpoint. Start timer, boom, 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 come back, end timer. And now I can actually see the request as well. I get that request ID, and I said, that's 2,400 milliseconds. 2,400. Our SLA, don't forget, was 2,000. We have a problem now. Now I can take that request ID, subscribe to a Kafka topic, or use KSQL, for example, in Kafka, to be able to say, given this request ID, please show the traceability of where that went through the system. That's how you tie all this together. And now I can see 20 milliseconds, 40 milliseconds, 30 milliseconds, 20 milliseconds, 210 or 2,100 milliseconds. It's like, whoops, there's the problem. And so it's easy to find that traceability. The auditability that somebody had asked is also the same thing right here. Not only from the auditing piece right here, but also having this request ID with the context, I can now audit exactly what is happening all the way through my system. All right, this is fantastic. Did you notice anything hold on one second. Did you notice anything common about all of these right here? What's common about all those good, and those are green check marks. You know what's common about those? You got it. Wait, oh, there you are, Mr. Cross-Cutting. Those are all cross-cutting concerns. Exactly. That's why I said you will need a gateway. You will need one because there's no other place to put these cross-cutting concerns than in a gateway. And if we federate the gateway, then we handle things like single points of failure and performance bottlenecks by making these small domained gateways. Yes, now, if you don't want a gateway, you can use a service mesh, which basically, think about it now as a distributed gateway. That's all a service mesh is. It's a distributed network infrastructure. Now, it handles additional things besides this. Specifically, it has circuit breakers, inter-service communication, yada, yada, yada. But the point is that we need that cross-cutting concern. And so gateways are very, very popular for doing that. Okay, now, but because we have a gateway, what is it implemented in? An ESB. Shouldn't we just simply do orchestration then there anyway? So what if I'd used the gateway for orchestration? Oh, no. No, please don't. Because orchestration, as you see right here, is a piece of code. It's a piece of software code. I have to write code to orchestrate. I have to orchestrate. Now, orchestration is the orchestra. I am going to be the conductor. And in order to do get all customer data, it's all of you guys in the first 2 rows right here. All of you folks. So, I've got a question, don't I? Can I call all of you, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 of you. Can I call all 13 of you at once? All in parallel? Nope. I can call the 4 of you at the same time. But you require additional information that you're supplying. And so now I have to call all 4 of you, then I can call you. And then I can call the 3 of you in parallel because you need information additional. And I'm aggregating all this as I go along, and then I can call all of you folks. What happens if you time out, though? Oh, do I fail it? No. I return what I can, hopefully, and keep trying. There's a lot, so I got error handling. There's a lot that I'm doing as an orchestrator. And the point is, let's just put that code up here in those message flows. Why do I have the red X's there? That is not a cross-cutting concern. So that's what I meant about don't leverage a gateway. Because why? Let me show you. We are breaking the bounded context. Watch this. Here's our wish list. You see the wish list service right here in the code? Okay. I make a breaking change. I change wish list. Okay, now, what can I do? A hot deploy. Ooh, no. Because look, the gateway is calling me. So now I have to make changes up here in the gateway. All right, so that's not a big deal, is it? What do I need to deploy? I need to deploy the entire gateway. Can I do that right now at 4:20 p.m.? No, that happens Wednesdays at 2 a.m. But wait a minute. We had push-button deployment. I mean, we had literally continuous deployment environment. There's no ceremony here in this wish list. It's just a microservice. It's a bounded context. Do you notice I can just deploy anytime I want to? Oh, no. By the way, did you test the entire hub? Well, no. How do you know you didn't break any other flows? Well, you know what we just built? We just built a monolith. And I've just broken my deployment pipeline. Agility went out the door. Testability went out the door. Deployability went out the door. Scalability went out the door. Fault tolerance went out the door. Because if that gateway goes down, boom. Yes, if the gateway goes down, everything goes down. That's why we don't want to leverage those. Okay, I get it. How do we do it? Well, just add it to the client. No, that's another bad thing. We, of course, don't want to do that. What we do is we actually create a orchestrator. So watch this. This is called the service orchestration pattern. So get all customer data. Well, we have an API or a gateway. So what I do is I create another microservice called a microservices orchestrator. And this does one thing. It's a microservice. It's single purpose. It's fine-grained. It does one thing really, really well. And you know what it does? It has, watch this, it has the code, all that complex code I just saw to do parallelism, aggregation. It has its own model. And it knows how to go to demographics, wish list, and preferences. This is a separate microservice. Yeah. Now, watch what happens here. If I say, no, this endpoint, by the way, this is get all customer data. That's the endpoint. And each of these microservice orchestrators are bound to each request. Every request has its own microservice that does that orchestration. So now can you see, if you've got 80 microservices that are handling about 200 requests, and 50 of those requests are orchestration. I forgot how many microservices we had. 80, right? Now I've got 130. Because each request has its own microservice. You can start to see how the numbers, and that's only one instance. You can start to see how the numbers rise. Now watch this. You misunderstood me. I didn't mean all customer data. I don't want the preferences. See the preferences? I don't want those. Where do I make the change? In one microservice, agility, testability, deployability, scalability, fault tolerance. And what do? I modify that code and I deploy. Now, let's do apples to apples though. I make a change, a breaking change to wish list. Remember that from before with that gateway? Well, who is calling me? Which orchestrators are calling me? That orchestrator right there. So I have to make the change to the orchestrator, but now watch my deployment. You ready? Type, enter. That's what I deploy. 2 microservices in a hot deploy environment. Yeah, these are really powerful. That's how you do orchestration in microservices. This is a very, very common pattern of being able to handle this.
But in this case, if there is a breaking contract change, then the event there is no need to change the proxy layer because that is just passing the request to the microservice. But there will be a change in client side.
Yeah, when I say the breaking change, this is a contract change. Yeah, so that's a good point, is that I am breaking the bounded context a little bit because now somebody else knows about me and they have my contract. By the way, somebody had talked about GraphQL. This is another place where I might implement GraphQL as well. to be able to do that orchestration and aggregation, because think about our responsibility. I'm in love with this pattern right here. I'm in love with it because think about this. Okay, do you remember a microservice? Demographics, wish list, preferences. Let's pick on wish list. What does wish list have in it? It has code, and it has data pertaining to what? A wish list. And it has a business domain called wish list. I have to have an object model, an object grid or an object model that represents what I'm returning to you as a wish list. And that might be JSON or it might be XML. Get all customer data. That's a whole different model, isn't it? A whole different domain. And so I'm pushing that responsibility onto a whole separate microservice because I don't want to pollute any of these microservices with those aggregation models. Separation of concerns, single responsibility principle. So yeah, that's the orchestrators. I really love these. But let me show you something else. Here's a benefits application I talked about before. This is where every state in the US, and I'm sure every state here, provides benefits to its residents. Child care, dental coverage, utility assistance, health coverage, and all this. As a matter of fact, in the state which I'm working in, there's 140, we call them programs of assistance. You know, if I don't have much money, my heat's about to get turned off, or in this case, the AC, and I've got kids at home, the government will pay your utility bill for you. And so there's 140 of these. Okay, so keep that in mind. Let's round it to 100. Okay, so there's 100 programs of assistance. Okay, are you ready for this? This is actually a great example of microservices. A great example of microservices. Why? Because each one of these have its own rules for health coverage, own rules for child care assistance, foster care assistance, all these kind of things, and all the data and benefits eligibility. However, riddle me this, Batman. What benefits is Mark actually receiving? Oh, well, that's just an orchestration, isn't it? Uh-huh. I'm going to make 100 RESTful calls. That's our first problem. Just run them in parallel. Yeah, is anything going to time out on that? Probably. But let's go down another level. I am making 100 database calls, aren't I? If I'm sharing the same database schema, now I'm sure, we all have our own schema, but all these are not separate physical databases. No, you know what these are? Those are separate schemas that are in the same database. So I have a single database instance. How many database connections do I need from that single database for this one request out of thousands? 100 database connections. Do you see the problem that starts to occur when we start to deal with this level of granularity? 100 database connections consumed for one request just to find out how many benefits I have. Orchestration will never, ever work for this. So you know what we have? Another pattern. And it's called the Microservices Aggregator pattern. And so the service aggregation pattern puts here a benefit aggregator. This is a separate microservice. It does one thing really well. It knows how to return the number of benefits I have. Now notice, separate from the orchestrator is stateless. The aggregator has state. As a matter of fact, these utilize something called data pumps. So watch this. I've got a queue right here. Every time Mark gets a benefit or gets a benefit removed, each of these services asynchronously pump that information, fire and forget, to a queue. Just blindly send that information. Mark just got childcare. Mark just got utility. Mark no longer has dental. And so now the aggregator listens on that queue, receives that information, and updates its own database or its own data. Now, data duplication? Yes. What data am I duplicating? Out of the thousands of attributes, I am duplicating two pieces of information, the name and the benefit. Now, this is the endpoint right here. What benefits does Mark have? Zoop, goes down here, makes about a 7 millisecond database call, and returns back the information because each request, like an orchestrator, has its own aggregator. Now, here's what's interesting, though.